checking if you can hear me or not. Yeah, hello. Yes, okay, wonderful. Thank you. All right. Very nice to meet you. I will just wait for a few more minutes and then we can start. Good morning, everyone. Hello. Okay, so probably I will start now. Good morning, everyone. My name is Clark. I'm a CE Chief Examiner and also the lecturer for the FIT 2107 software quality and testing. And yeah, thank you everyone for coming. I will just go through the lecture now. Okay. Yep. So today, this is the teaching staff for our unit. It seems that this unit is quite large. We have 250 students for the Clayton campus and a few hundred students for the Malaysia campus as well. So we have myself, my name is Clark, the CE and the Clayton lecturer, together with the Lillian. She's a Malaysia lecturer, and we have Norman, who is the Clayton head tutor, and Shun, who is the Malaysia head tutor. And we have 1, 2, 3, 4, 5, 6, 7, 8 tutors for the Clayton campus. Here we have Dr. Sarah, Danushka, Kai, Han, Minghua, Wanita, and Anthony. So I hope that everyone will attend one of these sessions with the tutor. Okay, just to give you a background, right? Like why do we need to enroll or study about software quality and testing, and what is the purpose of this unit, right? Think about when we develop a software, we want to ensure that we want there's no bug, so it does not cause any loss to the companies or the organizations, right? So that's why we need to learn about modern software quality assurance and the software testing tools and the techniques, right? So this kind of techniques will help software engineers to assure whether the software system that we develop to the end users or the customers are of high quality or not. And because there are lots of tools and the techniques, and there are different aspects of the quality attributes as well. For example, functionality, correctness, reliability, performance, human usability, security issues. So we will go through this kind of aspect together as well. All of these aspects are very important. And yeah, we can, it's not just only the technique, right? We need to learn like how to design the test case as well. Let's think about, there's a summation function, A plus B, we can test anything from 1 to 100, right? And that means this kind of test case are quite redundant. They are not systematic at all. They may not be the edge test case. So should we have, I think the key question is that how can we effectively design the test cases so we can test the program in the minimal resources, right? And yeah, so because there are so many test cases, we will learn about how to do the test automation as well. So we will talk about the CI and the CD pipeline. We'll go through about that later. And yeah, in the past, we can use like pair programming to ensure the quality of the code. But when the software system is at the large scale, like think about Android system, think about the iOS system, Windows system, that kind of thing, we need a more like a modern approach, or it's called modern code review. So yeah, we will go through about that as well. So that means once you complete this unit, right, we expect that you will be able to analyze and identify the software quality attributes for a small to medium-sized software system. You can also develop a software quality assurance plan or software testing plan to select like appropriate quality assurance and testing strategies. And you can also design test cases using black box and the white box testing techniques based on the user requirement as well. You can conduct automate unit testing using CI frameworks and system testing. And you can also analyze and report code quality issues using modern code review practices with tools and the measures as well. Let me see. Yep. I also just want to make sure that right now, yeah, the lecture is recorded. Okay, so so this unit, right? We will go through the unit over the 12 weeks during this semester. This is the structure of the unit that I designed. To be honest, in the past few years, the content is quite similar, but the structure is quite similar. But this year we try to modernize the content compared to the previous years as well. So these are the topics over the 12 weeks. First week we will go through about what is the software quality assurance. What do we need to know about the quality attributes? And then in the week 2, we'll talk about the introduction to software testing. What is the purpose of the software testing? What are the testing techniques? How can we design the test cases as well? How can we plan? How can we gather requirement, analyze the requirement, and write the acceptance testing, acceptance test criteria as well. And it's not just only about the planning, right? We need to decide the program at the smallest module, which is called unit, right? And then we need to test them, unit function. So it's called unit testing. We need to execute the test case as well using the CI, the CD, continuous integration and the continuous delivery. Yes, these assignments. Okay, yep. And week 4, we will talk about the black box testing technique. And week 4 and the week 5, black box. Week 6, 7, white box. Week 8, we talk about the code quality, technical debt, and how can we use the static analysis. Week 9, we will talk about the code review. Week 10, we talk about software metrics. We cannot improve it without measuring it. So we need to we will learn about how can we measure the quality of the software system as well, right? And then week 11, which is very important, we will talk about the software security, what are the potential failures of these kind of security issues and how can we detect or prevent it as well. Week 12 is going to be like a wrap up, or we can invite an industry guest speaker as well. So this is still pending in the plan. If I have any update, then I will let you know. All right. Okay. For this unit, the nice thing is that there's no exam. Okay. So we have only 4 assignments within the semester. The assignment is the first one is about quality attribute test plan and the unit testing. We expect to release the assignment one roughly the beginning of week 3. But if we can do by the end of week 2, that would be great as well. So it depends. We are working on it at the moment. And then we will release another assignment, the assignment 2 for the during the week 6. Okay. And we will release again the assignment 3 at the week 8 and the assignment 4 at the week 10. Okay. So if you look at the unit structure, you will see that each of the assignment will follow the content of the lecture and the studio. So please try to attend the lecture and the studios so you know how to work on the assignment effectively as well. Okay, so the actual submission date and the submission instruction will be provided in the assignment sheet. We will let you know later as well, because this unit does not have an exam. So that means there's no hurdle according to the handbook. What we mean is that you just need to achieve a unit mark of 50 or greater to pass the unit. All right. And by the way, for those who join later, if you have any questions, please post a question in the Zoom chat as well, Q&A. Okay. So we got a question. Are these assignment individuals or group assignment? Yes. So it's a mix. Okay. We are working on it at the moment. We will let you know. Yeah. Okay. But normally we will. Yeah, it's a mix. Yeah. group as well and the individual as well. All right. Okay. So for over this unit, right, Fit 2107, these are the learning activities. First of all, we will have lecture. It is an online lecture only. We will run it via Zoom, which is this one. Okay. And the slide, normally we will publish the slide in the ED STEM. Okay, so if you go through the ED lesson, this one, yeah, you will see all of the slide materials, learning activities that we will use for the studio as well, or the workshop, right? So we will use less Moodle, but more towards the ED. Okay. Studio, it will be weekly. So the purpose of the studio is that we want to allow the student to apply your skill in software quality and testing, and there will be some TA to support you as well. Okay. For the assignment, yeah, as I mentioned before, there are 4 major assignment tasks. The discussion, if you have any questions, please go through the ED STEM ED forum only, okay? And if you have any admin issue, technical issues, team issues, please email to the role account, this one, fit2107.clayton-x@monash.edu, okay? The most important thing is that please try to avoid, okay, don't send an email directly to the CE and the lecturers, okay? So please go through the head tutor first or the tutor, and they will try to resolve everything. They will discuss with me in the background, all right? There are a few questions. Let me read a little bit. There is a dozen of us waiting for an offline seminar in H2 theater. We register for an offline seminar. Yeah, it was meant to me that there was a mistake. Yes, that's right. Thank you, Dia. Yeah. So are these team assignments, and can we choose our own teams? We will let you know later, okay, about the assignment. Okay. The most important part is about the academic integrity and the plagiarism, okay? What we want, please try to avoid, okay? Any plagiarism, collusion, cheating, assisting someone else to cheat, fraudulent work. Monash is very serious about the plagiarism and treat it as a very serious offense, okay? Misconduct. So I just want to note that a penalty will appear on the academic integrity register for 7 years or 15 years when the penalty is exclusion, right? So I'll try to avoid. We can discuss further if you have any difficulty to complete the assignment, but try to avoid the plagiarism at all, okay? Yes, on the Allocate Plus, there's a workshop. Is that the studio? Yes, that's right. That's right. That's the is the mistake from the timetable. If you look at the handbook, it shows that the learning activities will be the lecture and the studio. So that's the mistake from the timetable. I already sent an email earlier today to correct this one. Yeah, I will let you know if we have any update. Yeah. So today the learning objective is that today the learning objective is that we will learn about what the importance of the quality in software system and different quality attributes as well. We will talk about the concepts of the software quality assurance. We will describe what is the purpose of the software testing and what are the approaches as well. Okay. Yeah, software quality and testing, what it is about. Actually, it's all about the software quality and how to evaluate the quality of the software. Yeah, basically it's like that, right? And when we develop a software system, whether it's going to be the website or mobile apps or whatever, software quality cannot be compromised at all. You have seen like previous news, right? About Telstra, about Optus. It caused like $1 million loss at all, and the reputation to the company. So that's why quality of the software system cannot be compromised at all. Yeah. Okay. But when we talk about what exactly is the software quality, right? So we define it as the degree to which a product or process meets the requirement or not. Normally, when we develop a software system, we need to extract the requirement first, come up with the requirement, what the software is supposed to do, right? And then we will the process to ensure that the product or the process meets the requirement. That's about the quality, okay? So when we talk about the quality, there are different aspects as well. So that's why we need to talk about the quality attributes, okay? So quality attributes could be something about reliability, dependability, correctness, and security. Yeah, and because quality is we want to ensure whether the product or the software is of high quality or not. That's why we need software testing technique, okay, to ensure that the product meets the quality, meets the requirement, okay. So software testing is the techniques or the tools to find bugs and the faults, okay. And software quality is everyone's responsibility. It's not just about the software tester at all, but it's for the whole team. This is very important. It's the team responsibility. That means as a software engineer, right? When we write the code, it's not about we write the code or the test, but software engineers should write the code and the test as well, not just or, but and, okay? So we got one question, are these slides available somewhere? Yes, they are available on ED-STEM, yep. Actually, it is available now on the ED-STEM. I will send the link to you now, yep. In the Zoom chat, all right. Okay, yeah, we will just talk about the importance of the software bugs, okay? Yeah, I try to do some research about this as well. This is purely about my research topic, right? And yeah, what we found is that it has been reported that software bugs actually cost like over like several $1 trillion globally, like not just only in Australia, but everywhere in the world, right? It is very costly. Think about like a rocket failure from what is that, SpaceX or that kind of thing. So like one defect actually costs like $1 billion. And what we want to avoid is that, we need to have an effective software quality assurance and the testing approaches to ensure that there's no such kind of bug at all, right? Like let's say within Australia, as you can see, lots of news. The Woolworth, right? When you go to the checkout counter register and you want to check out, but unfortunately, if the checkout system is failed, right, then you cannot purchase any, you cannot do any grocery shopping at all. So that's appears in the news as well in 2017, right? And think about another one is about the Queensland Health. This one, let's say if you use like some medication software, right, to recommend like how many doses, that kind of thing. But what if there is a bug and then the software overestimate or underestimate the amount of the medication that a patient should have, then it could kill you as well. So we should avoid that kind of thing, right? Okay. And so Commonwealth Bank credit card and loan disappear in an online banking outage. Let's think about like a mobile apps for the banking system, right? Mobile app banking. And if it fails, then you cannot do any money withdrawal or deposit. You cannot transfer the money, purchase anything. That's the failure of the online banking outage. So this is just an example, right? Of the potential failures of the software bugs, and we should try to avoid it, okay, as much as possible. But nowadays, actually, there's one question is telling me I'm not enrolled in ED. Can teaching staff add me? So actually, you need to go to the Moodle first and click the ED STEM from the Moodle, and it will automatically enroll you, to the ED STEM. Okay. Yeah. Thank you. So nowadays, software evolves extremely fast, right? Let's think about like a ultra large scale software system like Facebook app or Mozilla Firefox or Ubuntu operating system. So this kind of software system, it was written in multiple languages. People use Python, Java, JavaScript, TypeScript, or whatever by many people as well for a long period of time. It's not just like a 1 year project, but this was done like over 10 years, 20 years. Okay, so and there are different purposes of writing the code as well. It's not just only fix the bugs, but we can add the new features, improve the code quality, improve the maintainability of the software system as well, right? And because and right now we work at the like a pull-based software development style, like for example, the pull request. The code change or the commit was changed like every month, every day, every seconds, right? There are lots of code changes, and software right now they release very fast. It's not like a traditional style waterfall, but we basically release like every day. We release the new feature every day. Then the key question is that how can we effectively and efficiently assure the quality of the software system at the lowest operational cost, right? So I mean, frankly speaking, if we have like 100 years, we can test like every line of code, but actually it is infeasible, right? Because we have limited time and the resources. Like as a software engineers, we work so hard, but the business just want us to release the new feature, let's say tomorrow. Then how can we test it effectively to assure the quality as well? This is very hard. It's a real world scenario. That's why we need to learn about software quality and testing to design and test the software effectively. Okay, we cannot do it manually at all. Okay. When we talk about the software quality assurance, by definition, it is a set of activities or the processes aimed at ensuring that software products meet the quality standard, right? And when we talk about the quality standard, it could be ISO, SPICE, CMMI, this kind of thing, this kind of standard to fulfill the customer expectation. And basically, there are three goals of the software quality assurance. Okay, first, to ensure that the product has the desired quality properties and ensure that the process was built is of sufficient quality as well. And yeah, so the goal of the SQA, we focus on both the product and the process, not just only the product alone. Okay. Yeah, and when we talk about the quality, right? There are basically like these few people, like these three groups of stakeholders who care the most about the software quality. End users, of course, because they directly use the software. The development team, of course, they care about software quality because if there is anything happen, if there is something wrong, they have to fix them, right? And the sponsor means the companies, right, who pay the salary to the development team, okay, to create the software. So if there is anything wrong, they are responsible for that cost as well, okay? And it costs a lot in not just only the money, but also the reputation of the organization as well. Okay. When we talk about the software quality, there are three important aspects. When we look at we talk about the goal of the SQA, we look at both product and the process, right? But in terms of the product, we need to look at both aspects, okay? Functional quality and the structural quality, okay? Product, there are two types of the quality attributes for the product, okay? Functional means that whether the product meets the requirement or not, right? And the non-functional is about the characteristic, about the architecture. It is something that is not functional, but for example, usability, maintainability, that kind of thing, okay? Security as well. For example, if we have a feature that allow user to do the login, right? If we only test the functionality of the login system, login module, right? Just check whether the username and the password passed is matching the database or not. Then the user can log in. But non-functional, we need to think about the security part of the login system as well. Okay, we want to ensure that someone else cannot steal the credential information and log in. For example, that's why we need to have like a two-factor authentication, that kind of thing. okay? And yeah, process quality, we want to ensure that the process, the software development process is of high quality as well. If we use like a inefficient software development process, then we cannot deliver anything that is of good quality, okay? Yep. When we to ensure that the software to ensure that software is of high quality, right? We need to have like a good management system, and which is called product quality management. There are 4 activities involved as part of the product quality management, okay? First one, we need to do the planning, okay? Plan means that we need to define the process, document the process, or about like which quality standard that we want to meet, or what quality attributes that we want to consider, what are the requirements, and who will do it, and which technique are we going to use. This is mainly about the documentation process. And quality assurance is the process to manage the quality. There are lots of activities that we need to do, right? Control is about the process to measure and determine the quality level of the products. And the quality improvement, once we do everything, by the end of the process, we basically can do a reflection about what went well in the past, what can we improve in the future to optimize the process as well, okay? So this is a general product quality management, okay? And yep. So I will go through step by step. We will talk about planning, assurance, and approaches, okay, in the next few slides. Planning, as I mentioned before, the goal is to document the process, right? What are the software quality assurance activities that we want to do? Define the process. And normally we will document about what the quality requirements are, what are the quality attributes that we want to consider, what are the set of activities, processes, standard, that kind of thing, and what are the design levels of the quality as well, okay? When we document the process, right, when we do the SQA planning, it is beneficial to everyone because everything is documented, everyone is on the same page, and we can we can assess as well whether SQA is being done according to the plan or not, right? Otherwise, let's say we have 10 engineers, everyone just do their own thing without the standard, without the policy or the guideline, then we cannot ensure whether we are on the right track or not as well, right? Okay. And actually, SQA planning is more like a waterfall style for mission critical system. Okay, it is very document heavy. So these are some of the table of content. As I mentioned before, yeah, we talk about the roles and the responsibility, who will be responsible for which module, and what is the purpose, what standard that we are going to meet. Okay, and that's an example, okay? Yeah. So when we talk about the quality planning, right, as I mentioned before, we need to look at the quality attributes. So these are the general idea of the quality attributes that we can consider. This is based on the ISO standard 250110, okay? And in the past few slides, we talk about product quality, and we look at the functional and the non-functional, right? And so when we look at the functional quality, okay, so we look at these 3 aspects of the functional quality attributes here: functional completeness, functional correctness, and the functional appropriateness. The rest of these will be the non-functionality, non-functional quality attributes. Okay, they are related to the non-functional requirement. All right. In reality, when we develop a software system, we need to write the business requirement. What are the requirements of the software system? Then we extract which one is related to the functionality or the non-functionality. And then we can define what are the quality attributes that are associated with that requirement. All right. Okay. So Yep. In the next few slides, basically it just define, right? The definition of these these quality attributes. Okay, so these are very confusing: functional completeness, correctness, and the appropriateness. Basically, what does it mean? Okay, functional correctness is about the measure of how well the system or a component meets all of the state requirement. Okay, when let's say the system has 10 requirements, we can complete 10 we develop 10 functionality 10 functions, okay, to meet the requirement. That's the functional completeness, but it does not mean that each of the function is correct, right? So that's why we need to have another measure which is called functional correctness, to measure whether each of the function is performing its intent task or not, right? It meets the requirement or not, okay? So they are quite similar, they are related, but they are different, okay? Functional appropriateness measures the degree to which the system or component meets the user expectation. So it evaluates the system or component ability to perform the task it is expected to do in a way that satisfies the end user, okay? For example, if let's say if we implement a login function, okay, if we put the username, the right password, we can log in, right? The system just check whether the username matched with the password or not. Yes, the functionality is correct, right? But whether it is appropriate or not, that's another story. For example, if we enter the right username, enter the right password, but we cannot log in, okay? It means that if how can I say, the system return that username and the password is correct, but we cannot enter the system, then it is inappropriate, right? So that means functionality is correct, but it doesn't mean that it works, it performs in a way that satisfies the user, okay? So that's why we need to consider 3 different aspects of the functionality. It's not just only the functionality correctness, but it should be about whether it is appropriate and it is completed or not as well, okay? And these are the non-functional quality attributes. I will not go through everything. It is quite understandable. It is quite intuitive anyway. But if you have any question, we can discuss more during the studio as well, okay? Because I'm aware of the time, we have 30 minutes left. Yeah, so I will talk about the software quality and testing approaches now. Code inspection or that kind of thing, code review, okay? Yep. Mouse. And another technique, right? Another software quality assurance and testing approaches. This is the waterfall style software quality assurance. As everyone knows, waterfall is very sequential. We start from the analysis, requirement specification, design, implement, and then do the testing, right? So testing here is just one separate phase, okay? We will do like do the requirement analysis, do the test plan, development the test case, execute the test case, and then do that kind of thing, repeat it. So if the requirement is changed, these are some of the limitations, right? If the requirement is changed, then we cannot change anything. Yeah. For the calculator, and what were you going to say about the plus and the minus sign being swapped around? Yes. Okay. Maybe I'll just repeat this one again. Okay. Yeah. So I mentioned about the calculator app. Let me try to draw here. Okay. Let's say this is a calculator app. Okay. This is a display. This is the plus and the minus. Okay. And multiply here, right? So when we implement the summation function here, okay, we implement it correctly, which is good. That means that is done at the unit level. But when we design the calculator app, normally the order should be start from addition and then subtraction and then multiply, that kind of thing. So for this case, okay, we build the product, right? Yes, the functionality of the subtraction, addition, and multiply, everything is correct in order. Everything is correct, right? But are we building the right product? Of course, no, because when we test this calculator app with the end users, they are not happy at all. Why we put the subtraction before the addition, right? So that's why it's not just only we build the product, right? But we need to ensure that we build the right product as well. Yep. Okay. Clear? Thank you. All good? Okay. And I will clear my screen, clear my drawing. Yep. Okay. Yep. So that's the waterfall, right? So waterfall, when we don't understand the business domain and the requirement, then the static testing cannot be done appropriately at all. And the challenge part, I think the big disadvantage of the waterfall style software quality assurance here is that when the requirement is changed, we cannot change anything. Testing has to be done. Like we cannot do anything else. Okay. So that's the limitation. And surprisingly, right, most of the time, when we talk about the defects or bugs or that kind of thing, most of the time, the majority of the bugs are introduced during the requirement and the analysis design. When we collect the requirement at that time, nothing is mature. Everything is blurry and it's unclear. That's why most of the bugs are introduced there, but we don't know it until we actually implement it and test it, right? And then we discover that, oh Jesus, we didn't talk about the order of the button in the calculator at all. We just talk about what the system should be, right? Should perform. Just summation, subtraction, then subtraction. So that means, as I mentioned before, most of the bugs are introduced early, but were detected at the end of the software development phase, and it is very costly. We are about to deploy tomorrow, and then we just know the bugs. How can we prevent it, right? That's why we have a new software quality assurance culture. I would say it's a culture, it's a practice. The key question is that how can we shift the QA process instead of at the end of the software development process to the early phase of the software development, right? So that's why people call shift left testing, okay? And the purpose of the shift left testing is that we want to find the bugs as early as possible. We want to prevent it, not just detect it, okay? Prevent is better than cure, all right? So by doing this, developers can fix these bugs before they cause major problems, okay? That's a shift left testing. To do the shift left testing, right? Normally, we need to test the new requirement first, test the new code, test every build, test every deployment, test on production as well. So test every, we want to avoid, I need to rephrase this one again. We want to test the new requirement, test the code, test every build, but avoid, okay? Test every deployment, test on production. This is like a shift right, okay? We want to avoid as much as possible. We don't want to avoid testing on production. That means we implement anything, we want to test it, let the customer test it, report the bugs, we will fix it. Of course, if you consider this one as a mobile app, you will get a very bad reviews on the app store anyway, right? So that's why we want to shift the testing to the early phase of the software development. Okay, that's the concept of the shift left testing. And based on this figure, right? Yeah, the red line here, it shows that the cost of the software bug, cost of the fixing software defects, right? When we discover later, it costs like 640 times than the early phase of the software development. Yep. So that's why to do the shift left testing, right? That's why people have another practice is called TDD. Okay. TDD is a approach, okay, to develop the test case before the coding start. As I mentioned before, as a traditional software engineers, normally we either write the code or write the test, but in reality, to ensure the quality of the software system, we need to write both code and the test, okay, to ensure that the unit function that we implement is correct. But when we write the code and write the test, probably the bugs can be discovered too late. We didn't ship the testing process to the early phase of the software development. That's why the TDD concept emerged. We want to develop the test and then code, okay? Develop the test case first and code it, okay? So that's why it's called test first development. Based on the requirement, we write the test case. The requirement is to do the summation function. We write the test case first. Yeah, A plus B equal something. 2 plus 2 equal 5. 1 plus 1 equal 2, okay? And then we start writing the code. And that's a TDD, right? And that's the, now we'll talk about the DevOps testing. DevOps, because right now we are moving towards like a continuous delivery style of the modern software development. We normally do the planning, we code, we build it, we test it, and then go to the DevOps process, that kind of thing, okay? This is good. It is practice to reduce the barrier between developers and the operation. We can develop the code and deploy automatically. Everything is in the loop, in the continuous loop. But again, the DevOps testing is that testing is still considered as a separate phase in the continuous loop. It's not in the early phase of the software development anyway. It's okay. It's not ideal because the ideal case is that, as we mentioned before, we should shift the QA process to the early phase of the software development. That's why we need to have, it's called, no, okay, not yet there. DevOps testing, this is agile testing, okay? It's another practice, is another approach, okay? So basically it's about how can we integrate the testing process as part of the agile software development process. We want for agile, right? The key goal is that we want to deliver incrementally, deliver some value to the customer as much as frequent as possible, okay? But how can we do that, right? Agile is just a software development process, and waterfall style testing is at the end. For agile, what should we do? When should we test it, right? So we will talk about it now, okay? This is a very good book, okay? Agile Testing, a practical guide for tester and the agile team. It is written by Lisa Christmas and Janet Gregory. So based on this book, they mentioned that software testing is the whole team responsibility, okay? The whole team should be responsible for the software quality. It's not just only the tester, but everyone is the whole team responsibility. And every sprint, right, we should test it before we deliver to the customer. So the goal of the agile testing is to incrementally, frequently deliver the value to the customer, yeah, with some quality as well, okay? So in the agile testing is not the phase at all. It is part of the agile software development process, okay? So as I mentioned before, agile testing is the whole team responsibility for quality, and we will not consider the testing part as a department at all. Okay, like waterfall style, traditional software organization. This is a dev team. There's a QA team. There's a tester team. There's a QA department. We just implement the code with lots of bugs, let them test it. That's a traditional style. But here in the agile team, right, we should incorporate the quality culture into our mindset. We should develop produce high quality software in a time frame that maximize its value to the business. So as a tester, no, as a software engineer, they need to write the test case as well. It's the whole team responsibility, not just the tester or the designated quality assurance professionals. All right. So these are the 5 values, okay, for the agile testing. We should testing throughout, over testing at the end. Testing throughout, over testing at the end. We avoid testing at the end. We should prevent the bugs over finding the bugs. As I mentioned before, prevention is better than cure, right? We want to prevent the bugs as much as possible rather than detecting it at the end, right? Testing understanding over checking functionality, okay? Building the best system over breaking the system. Some testing approaches, they want to break the system, okay, to find the bugs, but we want to build the best system, okay? Yeah, and the last one, testing responsibility for is a team responsibility for quality rather than the tester responsibility. These are the 5 values for the agile testing. To do the agile testing, there are 3 methodologies here. First one, BDD, behavior-driven development. Normally, we just describe the behavior, let the system test it. For example, the 2 example tools, for example, Cucumber. You can Google it later as well. That's one of the BDD, okay? Acceptance test driven development. Normally, we write the requirement, write the acceptance test criteria, right? And then we will test the system using the acceptance criteria here, how the system should perform, okay? And we can also do exploratory testing as well. It's quite explore, it's not systematic at all. Because we mentioned before that DevOps testing, the good thing for DevOps is that we can continuously deliver the software, right? But testing is still considered as a separate phase in the continuous loop. It's not it's not start at the beginning. It's not chip left. So agile is one thing. Then how can we combine the agile and the DevOps testing together, right? So it's called holistic testing here. It is based on this reference, okay? Agile Testing Fellow, you can download this book as well. It is written there. That means instead of having the traditional DevOps, right? We plan, code, build, test, release, deploy, operate, monitor. That's the DevOps cycle. But for the holistic testing, we want to apply the testing practices throughout the DevOps cycle. That means we should start from the discover, plan, understand, build, deploy, release, observe, and learn, right? Testing is done early in the cycle. During the discover phase, this one, we should determine the value, test the idea, test the requirement, okay? Then when we plan it, we need to create the shared understanding. We need to identify the risk. What are the test assumptions? Create the testable stories. That means testable story is like a acceptance test criteria, okay? When we test it, yes, we use ATDD, acceptance test driven development. We use behavior driven development. For example, let's say we want to create a mobile app. We have a login system. We should not just test whether username and the password match the database or not. But when we do the acceptance criteria, we should have like step by step, right? Customer access the mobile app, and then whatever, go to the login UI, they input this and this. If the username and the password match with the database, it should perform like this. Otherwise, it should perform like this. That's how we test the scenarios, acceptance test-driven development. Okay. And then once we create the test case, understand everything, then we can automate the whole process as well. Okay, throughout the DevOps pipeline. Okay. Yep. Agile testing principles, right? So these are the 8 principles for the agile testing. Okay, first, we should continuous testing. We should, it's not just solely a separate phase in the DevOps or separate phase like in the waterfall. Okay, it should be done continuously. throughout the software development process. Okay. And then when we test continuously, we can provide the continuous feedback to the developers as well. Okay. And agile testing involves our tester is the whole team responsibility. We want to get the quick feedback as much as possible. We focus on the high level software quality. Okay. And then we focus on the less documentation as well. We focus on we will not write the software quality plan, SQA plan, that one. Okay, we just only have a brief description, just enough documentation. Less documentation does not mean that no documentation, just less than the waterfall, just enough documentation. This is what I want to emphasize. Test driven in agile testing, yeah, the product is evaluated at the time of the implementation. We implement the code, we test it immediately, not at the end. Okay, and we focus on the customer satisfaction. Okay, because I'm aware of the time, this is 10:58 now. Oh, okay, agile testing quadrant. Yeah. These are the agile testing quadrant. Okay, normally we divide the entire testing process into 4 parts. Okay, 4 quadrants here. The first quadrant, we focus on the quality of the code, and quadrant 2 is like a cycle. Okay, the first quadrant focus on the quality of the code. Second quadrant, we focus on the business-driven test cases. Okay, on the customer requirement, for example, test the scenarios is like V and V, but we rephrase as a instead of saying V and V, this is more like a quadrant. Okay, so first quadrant focus on the quality of the code. Second quadrant focus on the business-driven test cases. Third quadrant, we provide feedback for the previous 2 phases, right? And the fourth quadrant, we focus on the functionality requirement, for example, the performance, security, and the scalability. All right. When we do the agile testing, we will do like this. Okay, focus on the code, on the business, feedback, and then the non-functional requirement. Okay, and that's all for today. We talk about the software quality. It is very important. If the bugs are undetected, then it can have some serious consequence, monetary loss, reputation loss. We talk about software quality attributes, different one, right? So we will practice more during the studio as well. And we talk about different approaches of the software quality assurance and the V&V. So that's all for today. And then in the next session, next week, we will talk about introduction to software testing and a journey of a software tester. Everyone will practice as a software tester throughout the unit over the 12 weeks. Yeah. If you have any questions, yeah, please feel free to post on the ED STEM and or meet me at the studio as well. Okay. All right. That's all for today. Thank you so much, everyone. Bye-bye.